Fingerprint analysis seems airtight, right? For over a century, fingerprint analysis has been a cornerstone of forensic science. Law enforcement agencies worldwide have relied on the belief that each person's fingerprints are entirely unique, a biological signature as individual as we are. But what if this fundamental assumption isn't entirely accurate? Researchers led by Columbia Engineering's Hode Lipson, along with Wenyao Xu from the University at Buffalo, have made a discovery that could rewrite forensic textbooks. Their findings suggest that fingerprints from different fingers of the same person can share distinctive patterns. Patterns that traditional analysis has overlooked for decades. The breakthrough came when undergraduate student Gabe Guo trained an artificial intelligence system using a public database of approximately 60,000 fingerprints. The AI analyzed pairs of prints, some from the same individuals, others from different people, and learned to identify when seemingly different prints actually belonged to the same person. The results were remarkable. The system achieved 77% accuracy with single pairs of prints. When multiple samples were grouped together, the accuracy improved dramatically, potentially enhancing existing forensic methods by more than tenfold. What makes this discovery particularly interesting is that the AI wasn't using traditional minutiae, the branch points and endpoints in fingerprint ridges that forensic experts typically analyze. Instead, it detected patterns in the angles and curvatures of the central swirls and loops that human experts had missed. The path to publication wasn't easy. The team faced significant resistance from the forensic community, with one reviewer flatly stating, "It is well known that every fingerprint is unique." Their paper was rejected multiple times before finally being published in Science Advances. This resistance isn't surprising. The uniqueness of fingerprints has been accepted as fact for over a century, forming the foundation of countless criminal investigations and convictions. Challenging this belief means questioning decades of established practice. The implications for law enforcement could be substantial. This technology could help connect crime scenes, revive cold cases, and potentially even exonerate innocent individuals who may have been wrongfully identified through traditional fingerprint analysis. Of course, the researchers acknowledged the need for caution. While their system showed consistent performance across different demographics, they emphasized the importance of validating the approach with larger, more diverse data sets before implementation in real investigations. What's perhaps most remarkable about this story is that it represents a new kind of scientific discovery, one led by artificial intelligence and spearheaded by researchers outside the field in question. As Professor Lipson notes, this could be the beginning of an explosion of AI-led scientific discovery by non-experts. The study reminds us that even long-established scientific facts deserve continuing scrutiny, and that new technologies can reveal patterns hidden in plain sight for generations. As AI continues to evolve, what other scientific truths might be challenged? What other patterns might emerge from data we thought we understood completely? For now, the field of fingerprint analysis faces a moment of reckoning, one that could ultimately strengthen rather than weaken its contributions to justice. For more on this story, find a link to the article on Earth.com in the description.